Hi everybody, welcome to physics teacher classes. So our chapter is laws of motion, Newton's laws of motion. So we discussed Newton's first law, second law, third law and impulse, momentum, these physical quantities, and we have seen some numericals also, some important numericals. So today we are going to discuss about an important topic in laws of motion, that is free body diagrams. Free body diagrams, okay, and equations for force and equations for force. Okay, this is an important topic in laws of motion, right? In point of IIT, JEE and NEET examination and all other competitive examinations, this is an important topic. Listen carefully, slowly and easily we will learn this. Okay, yeah, come on, let us see what is meant by first free body diagram. Okay, now suppose let us take an example. A block or a body is resting on a surface. This is a surface. Here is an object resting on this. Okay, now I want to identify how many forces are acting on each body. Here how many bodies are there? Two. One is our block, second one is the surface. Okay, so if you write the forces acting on a single body, that is called as the free body diagram of that particular body. Clear? If you write the forces acting on a body, okay now, so that can be considered as a free body diagram. So in free body diagram we write or draw, it is a diagram, simply we are drawing the number of forces acting on a body. Okay, right. So and it is free from all the surfaces, so it is free body diagram. So in free body diagram we draw forces acting on the body, forces acting on the body. So here this is very important, forces acting on the body, not by the body. What is the difference between forces acting on the body, forces acting by the body? Okay, yeah, listen carefully. So let us consider this example. In this example I said two bodies are there. Now let us separate the first body as the block. Okay, now tell me how many forces are acting on this body. How many forces are acting on this body? So how many forces are there? Basically we have 7 forces. Okay now, right, in those 7, 3 are non-contact, 4 are contact, right now. So first we learn these free body diagrams and equations of force on a frictionless surface. On a smooth surface we are going to learn now. On a smooth surface, these are all. After getting some idea, after getting some practice, you will be learning on rough surfaces also, right? So that smooth surface, so in this friction is gone. So how many forces are there? 3. In this 3, in this section we are going to discuss about mechanics. So in mechanics there will not be magnetic force and there will not be electrostatic force. So 2 forces are gone. Then we got 1 non-contact force and 3 contact forces. What is 1 non-contact force? That is gravitational force. What are the 3 contact forces? One is applied force. Okay. Second one is tension. Okay, no. Next, third one is normal force. Now there is a possibility of 4 forces acting on the body in this lesson. Clear? What are those four? You concentrate on these four forces only: gravitational force, applied force, tension, normal. Now see gravitational force. What we discussed, gravitational force acts always on the body vertically downwards. So the force acting on the body, first one is gravitational force. Clear. Next, is there any applied force on the block? From up or down or sides? There is no applied force. If applied force is there, then that will be directed in this way. This is applied force. So there is no applied force also. Next, is there any tension? When tension force will come? Right. Okay. In the problem, if there is a string or rope and that string or rope is tightened, then tension will come. So there is no tension. You don't feel any tension. Right, Nana? Next, normal. When normal acts? When there is two surfaces in contact with each other, then normal occurs. So here see that this is one surface and block surface, both are in contact, so that normal comes. Now totally how many forces are acting in this case? Only two forces. Understood, Nana? Right. These two forces are acting on the body. Yes or no? Okay. Is gravitational force applied by the body? No. Gravitational force is acting on the body by the earth. Okay. Earth is pulling it. What is the direction of gravitational force? Vertically down. Let us take this as Fg. Next, normal. Normal is the force applied by the body or on the body? Force acting on the body. Who are applying that force? The surface. Okay, so the surface, as these two are in contact, the surface applies normal force on the body that is perpendicular to the surface, so that this is our normal. Understood? In this case, how many forces are acting on the body? Two forces. Now what are the forces acting by the body, sir? Now see that this body is in contact with the surface. So this body applies normal force on the surface. That is the force applied by the body. Okay, that force applied by the body on the surface is vertically downward, that is normal. That is not considered in the free body diagram of the body. So forces acting on the body is taken. Clear, Nana? Now these are the forces acting on the body. This diagram simply we are calling as free body diagram. What is that, Nana? Free body diagram. Clear? Now let us see next part. What are the equations for force? Now we write an equation for the calculating net force. Okay? To calculate net force, we write equations. So here two possibilities are there. So sometimes forces may act along vertically. Sometimes forces may act along horizontally. That's why, so along x direction let us take. Okay, along horizontally means let us take x, or let us take horizontal, no problem. Okay, horizontal and vertical. Understood, Nana? So these two cases are possible, along horizontal and vertical. In this case, there is no horizontal force. Yes or no? Along positive x-axis, negative x-axis, are there any forces? No. So only vertical forces are there. Now let us write the equation for force. Okay. Equation for force. Now these two are acting in the opposite direction. Then net force from free body diagram is N minus Fg. Yes or no? Okay. So because both are acting in the opposite direction, we need to subtract. So here you can write Fg minus N or N minus Fg. Don't worry, because the object is at rest. Understood? Right. So this is from the free body diagram. Now from Newton's second law, what is net force? From Newton's second law, F net is equal to M into A. Yes or no? Yes. Now we got two equations. This says equation 1 and this is equation 2. You remember, first equation is from the free body diagram. Second equation is from the Newton's law. Okay. Now these two equations we can combine because left hand side parts are equal, so that N minus Fg is equal to Ma. Okay. Now tell me, is there any acceleration for the body along a horizontal vertical direction? We are writing vertical forces. Okay. Is there any acceleration for the body along vertically, either upward or downward? No, it is at rest, so that acceleration will be 0. Okay, na? Understood? So that this will be is equal to 0. Since, what is the reason? acceleration is 0. When acceleration will be 0? When the body is at rest or the body is in uniform motion. Okay, Nana? Now from this I can write very simple, n minus fg is equal to 0. Then that is equal to n is equal to fg. Here the normal force is balanced by the gravitational force. Okay, are these two form action reaction pair? N and Fg form action reaction pair. They are acting in the opposite direction and they are equal in magnitude. Can they form? No. What is the reason? They are acting on the same body. Okay, na? So action reaction pair acts on the two different bodies. Here they are acting on the same body, so these two are not action reaction pair. And one more thing, here N is the contact force, Fg is the non-contact force. Yes or no? So action reaction pair should be of same nature. Here they are different nature. So these are not action reaction pair. Remember that. Understood, Nana? So this is a simple situation how to draw a free body diagram. Clear? Right. Now let us take another situation. Clear? Yeah. Now let us see another example where an object is on the surface. It is moving with a constant speed in a straight line. Constant speed in a straight line. Okay, na? So in this case, let us draw first a free body diagram. Now this is the body. Okay, only for the block we are writing free body diagram. How many forces are acting in this case also? Two, only two. Right, Anna? One is Fg downward, second one is normal by the surface in the upward direction. Okay, so only vertically force are acting. So net force in the vertical direction, F net is equal to, what is that? N minus Fg. From Newton's second law, F net is equal to how much? ma. That is equal to 0 since the acceleration is 0 because the speed is constant. Okay, here the body is at rest. Here the body is moving with constant speed, means uniform motion. So from these two equations one can write N minus Fg is equal to 0. N is equal to Fg. Understood? So very simple, Nana. First you need to identify how many forces are acting on it and what is its direction. Okay, so how many forces are there in this? Total there are 4 forces for us now. Okay, so you check one by one and draw their directions. It will be over. Now let us see another case. Okay, now this is an object. It is moving with an acceleration now. The body is moving with an acceleration now. Then what could be the net force on this case? Now F net is equal to, what is that, Nana? N minus M. Okay, na? N minus Fg. So what is the free body diagram? This is the free body diagram. How many forces are acting? Only 2 forces in this case. Clear? Right. So next, F net is equal to how much? M into A. Now we are writing forces in the vertical direction. Yes or no? But the acceleration is along horizontal direction. Then this will be is equal to 0. In the vertical direction, N minus Fg is equal to 0. Then N is equal to Fg. Right? Now what about horizontal direction? Okay. So do you see any force on this body? Horizontal direction? No. But without force, the body cannot accelerate. That's why this is the applied force. That is the applied force. Now horizontally how many forces are acting on it? Horizontally gravitational force will be there? No. Gravitational force always vertically downward. Is there applied force? Yes. Tension? No. Normal? In horizontally, is there any normal? No. Horizontally the body is not connected to any other. So then F net is equal to how much, sir? F. Only the applied force. Now from Newton's second law, F net is equal to how much? ma. Since it has acceleration, it is equal to ma. From these two equations we can write F is equal to ma. Understood? So vertically N is balancing Fg. Okay, horizontally F is equal to ma. Understood, Nana? Right. So in this way one can identify the forces and can draw equations for the force. Understood? Yeah, little bit difficult range. Let us move. Right, Nana? Right. Now in this situation, the body is on the surface. Okay. This is, let us say, M1. Another block is kept adjacent to this body, that is M2. Okay. Now both the blocks are at rest. Now let us see the free body diagrams and equations of force for M1 and M2. First let us see for M1. Okay. Now let us take only M1 the body. How many forces are acting on the body vertically first? Vertically, one is weight of the body acts downward. Second one is upward force by the surface, that is normal reaction. Let us take N1. Okay. This is about vertical nana. Okay. Now F net is equal to what? N1 minus Fg. From Newton's second law, F net is equal to how much? M1 into A, that is equal to 0, since there is no vertical motion. Okay. So both the blocks are at rest. Clear. Now horizontally. Okay. Now horizontally, what is the free body diagram of this? M1. Horizontally, any applied force is there? No. Now see that M1 and M2 are in contact with each other. Yes or no? Then when two bodies are in contact with each other, normal force acts. Okay, na? That means M2 applies a normal force on M1. That is equal to this. Let us take that as N2. Understood? Right. Only this is the free body diagram for M1. Okay. So along horizontal direction. This is along vertical direction. Okay. Here N2 is acting on the body. So you may think that this N2 is acting on the body so that the body should move. Okay. But the thing is here, these forces are treated as internal forces. What forces, Nana? Internal forces. How? I will explain. Now let us see for M2. Okay. For M2, what is the vertical free body diagram? Weight of the body acting downward. Let us take F2g, and normal by the surface. Let us take that as N3. Okay. Here I can write directly N3 is equal to F2g because there is no motion vertically. Okay. Now horizontally. So horizontally, what is the force acting on that? As these two are in contact, M1 applies a force on M2, that is normal, that is equal to N2. See here. Here M2 applies a force on M1. Okay. That is how much? N2. Now M1 also applies same force on body. Understood? So that is also N2. Now these two forces are called internal forces when you take that M1 and M2 are total system. Okay, na? So these forces cannot accelerate now the body. Right? Now let us consider another case. Similarly, now M1 and M2. Okay. Now a force is acting on the body F. F is acting on M1. Okay, now in this case, let us calculate acceleration of M1 and M2. Okay, now we are going to calculate acceleration of M1 and M2. Now let us see. So now I am not going to draw vertically free body diagram because vertically there is no motion. So we can neglect that. We can omit that part. Only the motion is along horizontal direction. Now write free body diagram for M1. Now on M1, how many forces are acting horizontally? Two forces. One is the applied force. Second one is the normal by M2. Let us take that as N. Okay. And it has an acceleration. Let us take A. As two bodies are connected, listen carefully. As the two bodies are in contact with each other, whenever you apply force F or something, the distance moved by M1 and M2 will be same. Okay. Because both are in contact. So when the distance moved by M1 and M2 are same, okay, by the application of same force, then the acceleration of m1 and m2 will be same. So acceleration of m1 is a1 is equal to acceleration of m2 is a2, that is equal to a. Okay, this total system will have an acceleration of a. Understood? And now from this, what can be the net force equation, sir? F minus n. Why? F is greater than n because the motion is in this direction. So F must be greater than that. Now from Newton's second law, F net is equal to how much? m1 into a. Clear? Now from these two, what can I write? F minus n is equal to m1 into a. Are you understanding or not? Right. Now for m2, you write the free body diagram. On m2, how many forces are acting? 2 or 1? Is F acting directly on m2? No. What is the only force acting? That is the force by m1 on m2. How much is that? That is the normal, that is equal to the force applied by m2 on m1, that is n. Okay, then from free body diagram, F net is equal to how much, Nana? Only n. From Newton's second law, F net is equal to m2 into a. Right, from these two equations, what can I write? N is equal to m2a. Understood? Right, now you substitute this n value here. Okay, now in this equation, then F minus m2a is equal to m1a. So on that side, F is equal to m2a plus m1a. If you simplify that, you will be getting F is equal to a of m1 plus m2, or the acceleration is equal to F by m1 plus m2. Okay, then the acceleration of each body is equal to net applied force by total mass of the system. Understood? Okay, this is very important relation, Nana. So the acceleration of each body, okay na, so each body will have same acceleration. How much is that? Simply that is the net force acting on the object divided by total mass of the system. Let us take an example. For example, there is an object of 2 kg, another object of 1 kg, and one more object of 4 kg are there. Okay, on this a force of 10 Newton is acting. Then what is the acceleration of each block? So acceleration of each block is F net by total mass. Total mass. Okay, now that is equal to F net. What is the net force acting horizontally? Only the applied force. Okay, you consider this total as the system. On this body, how much is the applied force? 10 by what is the total mass? 4 plus 2 plus 1. How much, sir? 7 meters per second square. Okay, in this way you can calculate very easily. And sometimes the questions may ask, what is the force applied by 4 kg block on 2 kg block? What is the force applied by 4 kg block on 2 kg block? That is equal to the force applied by 2 kg block on 4 kg block. Okay, that is called normal. Okay, how one can calculate normal? Now let us take 4 kg block free body diagram. Okay, what is the force acting on this? Only the force applied by the 2 kg block on the 4 kg. That let us take n1 or n2. Okay, now n1 is equal to m into a, means 4 into a. Okay, therefore n1 is equal to 4 into a is 40 by 7 Newton. Understood? This is the force applied by 2 kg block on 4 kg block. What is the force applied by 4 kg block on 2 kg block? Same. What is the force applied by 2 kg block on 1 kg block? What is the force applied by 2 kg block on 1 kg block? Let us see. For 2 kg block, what is the free body diagram, Nana? One is the force applied by 1 kg block on 2 kg block. Let us take that as N2. Second one is force applied by 4 kg block on 2 kg block. That is N1 already we have taken. On 2 kg block, two forces are acting. These two are normal forces only because the 2 kg block is in contact with the 4 kg block as well as 1 kg block. So two normal will come. Understood? And now from this, what is the net force? The motion is this side. force is acting this side. So N2 is greater than N1. So N2 minus N1 is the net force. That is equal to M into A. That is 2 into A. Okay. Now already we have calculated N1. Okay na. Therefore N2 is equal to 2A plus N1. Now from this you will be getting N2. That is the force applied by 2 kg block on 1 kg block. Similarly 1 kg block on 2 kg block. Got it? So in this way we can solve a simple numericals. These are very simple numericals, Nana. Understood? So next let us see one more numerical. One more question. Okay. So that is in this case, now the bodies are in this way. Let us see the situation. Okay. This is a wedge or an inclined plane. Right, Nana? There is an object placed on an inclined plane whose mass is m. Clear? Whose mass is m. Now the object is at rest, suppose. Then what could be the forces acting on m and what is its free body diagram? Okay. Now let us see. This is our body. Yes or no? Now first, how many forces will act? One is gravitational force acts vertically downward. Second one, normal acts perpendicular to the surface. This is the surface, so perpendicular. So in this way it will be your normal. Okay, Nana? Now see, in this case these two forces are not acting horizontally, not acting vertically. In this case what we need to do? Very good. We need to simplify or resolve any one of the force. Yes, let us resolve this weight of the body along horizontally and vertically. If you resolve this body, this is the vertical and this is the horizontal. Yes or no? So that this, right? So how much will be this? This will be Fg cos theta. This is the angle of the inclined plane, theta, and this is the F sin theta. Understood? Now this is our x-axis, this is our y-axis. Understood? This is horizontal and this is vertical. Now along vertical, let us see what is the net force. N minus Fg cos theta is equal to ma. Ma is 0. This is along vertical. Now what about horizontal? Horizontally F sin theta, only the force acting. So if F sin theta is acting downward, it should come down. Okay, why it is not coming down? Some force is acting in the upward direction. If this is the rough surface, then only it is possible. Then the friction will be acting in the opposite direction, so that friction is taken in this direction. Then F sin theta minus F, that is equal to ma. Ma is 0. Understood? These are the two equations for the force. Clear, Nana? So in this case, how many forces are acting on the block M? 3 forces. One is weight, second one is normal reaction, third one is friction. Clear, Nana? So total 3 forces are acting. So this weight we are resolving into 2 components. One is vertical and horizontal. Okay, this vertical component is Fg cos theta, where theta is the angle of the right inclined plane. Next, F sin theta. Now let us consider this as the vertical, this as the horizontal. Now for vertical, what is the net force? N minus Fg cos theta, F net. Okay, from Newton's second law, F net is equal to ma, 0. So N minus Fg equal to 0. Similarly, horizontally, F sin theta minus F is equal to 0. Understood, Nana? So in this way one can write the free body diagram and one can apply the equations of motion. Okay, sir, equations for the force. So in next class we will learn some more cases, interesting cases. Okay, right. Meanwhile you practice this and see the video carefully. Thank you.